Hey guys, we are. Give me 1 second to get this next quiz started up. End of the day today has gotten a little bit hectic for me. So, alright, let's go back to y'all's class. I had one guy coming in from a different class that wanted to have class today. Let's do the second one. I accidentally ended y'all's quiz earlier and had to put it back up, so. Alright, so in general, whenever you're working with two different values in a circuit, like inductive reactance and resistance, or capacitive reactance, like all of those things exist in every single circuit: inductive reactance, capacitive reactance, and resistance. But if one of them is just incredible amounts greater than the others, then you can ignore like the others. Like if it's 10 times greater than, you basically ignore what's, so small that it's not really making a change in the circuit. Okay. What is total current in this circuit? This one's real easy. Looks like we got a bunch of answers. I don't remember I think it's, let's see, total current. You have 25 volts here and 1,000 ohms. So 25 divided by 1,000 is what you're going to have for amperage. So that's 25 divided by 1,000, because that's just basic Ohm's law, right? It's a series circuit, so current stays the same in a series circuit. And so 0.025, so 25 milliamps is the winner. Let's see who it is. Tyler Irwin. Tell him what he won. More test. All right, so what is total voltage in this circuit? So this is a same circuit. So you have ER and EC. So in a circuit like that, where you have two different voltages in a series circuit, they are 90 degrees out of phase with each other, because you have your resistive voltage and your resistive voltage and your capacitive voltage. They're 90 degrees out of phase, so you put them on a triangle. Like so. Just all that time wasted drawing triangles. Alright, so we had 25 volts and 40 volts. Let's double check me. It is. So, we have 25 volts and 40 volts. They're 90 degrees out of phase with each other. So all you do is total voltage or applied voltage, whichever way you're looking at it. You're going to do E total is equal to the square root of EC squared plus ER squared. So let's plug these numbers in, see what we get. So we have square root, cleared. Okay, it's going to make me 40 squared plus 25 squared gives me 625, and we will take, okay. And then now we will take the square root of that. Your calculator may vary, but that's how I had to type it in my calculator. So it looks like 47.13. Obviously on a test it's going to be multiple choice. And doing the short answer, it usually limits y'all's answers to just a few things. But 47.17, 40.7, 47.17. I'd also accepted 47, 47.1, you know, things around there. 47.2. That's why I'd call correct. All right. What is the true power in the circuit in the figure below? So we have 350 ohms. Applied power is 24 volts. Z is 500 ohms. And I total is 48 milliamps. Okay. Oh, we have I total and R. We don't need anything else. So let's make our chart like we always do. I'm not talking to you, Grayson. Actually, so I have two first years. While I do this, I'll tell a story. I have two first years that one day they shared a phone, and like one of them messaged me, "Hey, this is so and so." So my phone went, "This is who it is," but it's the other person's phone. So now I have two phone numbers for one person. And so whenever they call, and their voices sound kind of similar, so I never know who I'm talking to. Like if they just went, "Hey, what's my grade?" I would have no idea what to say. All right. So we have Z, R, X of C, and X of L. I total, I, R, I, C, I, L. E total or applied. Let's just E R E C and E L. These bottom two rows don't matter at all. P apparent and P true. And I'm going to get into the question now. We got 350 ohms, 24 volts, and 48 milliamps. Was it 350? Man. 350 ohms. Okay. This one's very easy. So that's a series circuit. You can see that right here. You can see the circuit's a series circuit. So what do we know about series circuits? We know that current stays the same. So we can do the 0.048, 0.048, and 0.048. We don't care about the other two. All we care about is doing good enough. 350 times 0.048 amps. That's amps. I didn't actually look at the number. Somebody rewind and tell me what it was. 16.8. So now we know there was 16.8 volts here. And now we can take that 16.8, multiply one more time to get over to true power. So 0.048 is equal to 0.806. So 806 milliwatts. It's probably what the test is going to say, or the quiz. That's not the right page at all. 806. 806 it is. All right. Last and not least, a blank in an LC circuit will cause an increase in the capacitive reactance. An increase of the frequency. So just looking at your formulas, we're talking about capacitive reactance, 1 over 2 pi FC. We're looking for something that will increase capacitive reactance, right? Yes. So if you lower anything down here, it's going to increase XC, which is capacitive reactance. All right, so that's it. We're done. We got one more quiz, but I will see you in that one in like 45 minutes. All right.